This is for Year 12 Specialists. It comes out of the 2017 Specialist SAC TF Q, which is about complex numbers. Okay, question number 4 is about the argument of Z being equal to pi on 4. Now I know that pi on 4 is that angle there, pi on 4. So all of the complex numbers that have an angle of pi on 4 you will find along here, along this line, all of the angles pi on 4. But this has been moved to the left 1 and up 1. So if I'm moving it to the left 1 and up 1, I move to the left 1 to -1 and up 1 to +1. That's where I'm going to start. And my line's going to go across here. It's going to be a ray, and this angle in here is going to be pi on 4. So that's all of the complex numbers. I don't include this because at that point there, I'm at that point there. I haven't gone anywhere, so I don't have an angle yet. So if that's 45 degrees, then my rise over run will be 1, which means the gradient of this line is 1. And if the gradient equals 1, and this is at -1, 1, that y-intercept is going to be 2. So I have an equation in Cartesian form of y equals x plus 2, because the gradient's 1 and the y-intercept is 1. However, it has a restricted domain of x greater than -1. So to the next question, which is asking you to sketch it on this graph, well, I'm going to have an open circle there, and I'm going to have a line that goes like this, and that's the graph on that Argand diagram, where that's going to be at -1 and 1. Okay, so the next part of the question then says, if I can move this more easily, okay, shade this region. Now you'll notice that this is the same as what we have up here. So this thing here is starting at this point, all of the complex numbers that angles are bigger than pi on 4, not including pi on 4, bigger than pi on 4. So I have the pen highlighted and stay highlighted. I have an open circle there. I've got dashed lines. Why is my pen go off? Dashed lines along pi on 4. This over here will be a solid line, and the region I want is all in here, because all the complex numbers in here have angles that are bigger than pi on 4, up to pi, but there's nothing down here or here or here or here, because all these angles are less than. That's what that graph looks like. If I go over the page, I need to consider the graph with this rule. Okay, so what is this rule? I might change my color to blue and make my pen size just a little bit smaller. So I'm looking for the imaginary component of 2 don't have my thing behind. Okay, 2 times x minus yi x minus yi plus 1 minus I plus the real component of x plus yi plus 7 plus I equals 0. So I'm looking for the imaginary component of 2x plus 1, that's the real component, plus minus 2y minus 1, I, plus the real component of the x's are x plus 7 plus y plus 1, I equals 0. Now what it's asking for is just the imaginary component. So it's minus 2y minus 1, and then just the imaginary component, plus x plus 7 equals 0, minus 2y plus x equals negative 6, um, 2y is going to equal a half x plus 3, correct? Oh, I've taken the 2 over, so get rid of that 2. Minus x divided by negative 2 is positive a half. Minus 6 divided by negative 2 is plus 3. And if I'm going to draw this, which is this, intersect this, which is the region above, I'm going to have that's plus 3. I'm going to have the line which goes through at 3. It goes through at 3. And it has a gradient of a half. So it's going to go over 2 and up 1, back 2 and down 1. So it's going to go through down here at minus 6. So that's what this line is going to look like. And remember, I've also got this shaded region. So if I throw this on here, we're going to go from there to there. That's the overlap of that line and the region. I'll have a coloured in circle there on that endpoint, but I'll have an open circle there on that endpoint. And you need to work out the equations of those intersection points, because I know that this line is y equals x plus 2. My trackball's not really working. And I know that this line is this equation. I can set them equal to each other and do simultaneous equations. Okay, so that's how question 4 goes.